Introduction to Arithmetic Sequences. Hello, everyone. Today we're going to be looking into arithmetic sequences. An arithmetic sequence is a sequence of numbers where the difference between any two consecutive terms is always the same. And this difference is known as the common difference, and we usually denote it by the letter D. Understanding arithmetic sequences is important in mathematics because they form the basis in understanding more complex sequences and series. General form of an arithmetic sequence. So let's talk about the general form of an arithmetic sequence. An arithmetic sequence can be written in the following way: A plus D, A plus 2D, A plus 3D, and so on. Here, A is the first term of the sequence, and D is the common difference between the term. As you can see, each term after the first is obtained by adding the common difference to the previous term. So you see A plus D, and we are adding D again, A plus 2D, A plus 3D, and so on. If we are to represent this in Python, we can have function called arithmetic sequence, which takes the first term A and the common difference D and the number of terms N as inputs, and it generates an arithmetic sequence, and we're using list comprehension here in Python. And we are to use this and set 2 as an A, 3 as D, and as 5. This example generates the first 5 terms, starting from 2 with a common difference of 3. So the output will be a list that contains 2, 5, 8, 11, 14. Examples of arithmetic sequences. So let's look at examples of arithmetic sequences to better understand the concept. So let's first look at simple example. Consider the sequence 2, 5, 8, 11, 14, and so on. In this sequence, if we are to find what the first term A and the common difference D is, the first term A is 2, and the common difference D is 3. You can see that each term can be obtained by adding 3 to the previous term. Another example is the sequence 10, 7, 4, 1, -2. Here, the first term A is 10, and the common difference D is -3. And each term is obtained by subtracting 3 from the previous term. And if we're to look at Python code, we can reuse the arithmetic sequence function that we defined in the previous slide, and we can use this to generate 2 sequences. The first one with a positive common difference, and the second one with negative common differences. And the first sequence, as we can see, starts with 2, and the second one starts with at 10 with a difference of -3. Finding the nth term. In order to find any term in an arithmetic sequence, we use the formula. So nth term uh, is is A plus n minus 1 times D. So in this formula, A is the first term and B is the common difference and N is the term number. If we look at an example, say we have the sequence 3, 7, 11, 15, and so on, and we're interested in finding the 10th term, then here the first term A is 3, and the common difference D is 4, and we will need the 10th term. Using the formula, we would get 3 plus 10 minus 1 times 4, which is 3 plus 9 times 4, and this becomes 39. So the 10th term is 39. And if we are to use programming language Python, we can define a function called nth term, and the function nth term calculates the nth term of an arithmetic sequence using the formula a plus n minus 1 times d, and you can provide appropriate a, d, and n to calculate. And for this example, we're calculating the 10th term of the sequence starting at 3 with a common difference 4. Sum of the first n term. So the sum of the first n terms of an arithmetic sequence is given by the formula n divided by 2 times 2a plus n minus 1 times d. Alternatively, you can use n divided by 2 times a plus nth term. So if we look at an example with the sequence 2, 4, 6, 8, 10, and so on, in order to find the sum of the first 5 terms, we would find out what the first term is, which is 2, and the common difference d is 2, and we will need to use the formula. Then we would get 5 divided by 2 times 2 times 2 plus 5 minus 1 times 2, which becomes 30. So the sum of the first 5 terms is 30. And we can, if we were to use Python, we can define a function called sum of nth term, which calculate the sum of the first n terms of an arithmetic sequence using the formula. Applications of arithmetic sequences. So arithmetic sequences have applications in real life. So in finance, they can be used to calculate the total amount of a series of regular payments, such as installment plans or saving deposits. They are also useful in determining the depreciation of assets over time, where an asset loses a fixed amount of value each year. In scheduling, arithmetic sequences help in planning repetitive tasks at regular intervals, like weekly meetings or maintenance schedules, and organize events that occur periodically, such as annual conferences. In mathematics and science, arithmetics sequences model linear growth or decay, which can be seen in population studies or radioactive decay process. And they're also useful in solving problems that involve evenly spaced elements, such as distributing seats or calculating distances. And here is an example in finance, which is a depreciation of an asset. Just like what we've done, we would define the initial value, A, and the annual depreciation, which is D, and the number of years, which is N. And we can just provide this value as a into the function arithmetic sequence. Here are more examples. So we have 4 problems. We can go over each problem. So first problem says find the 15th term of the arithmetic sequences, 5, 9, 13, 17, so on. You want to first identify the first term A and the common differences, which are 5 and 4. And you want to use the formula for the nth term that we went over for the of an arithmetic sequence. And you want to substitute A, D, and N. For practice problem 2, say you want to calculate the sum of the first 20 terms of the sequence 3, 7, 11, 15. Then, as always, you want to identify the first term A, common difference D, and the number of terms N. And then you can use the formula for the sum of the first N terms. Practice problem 3. Problem states, given the sequences -2, -5, -8, -11, find the common difference and the 12th term. So first of all, the first term is -2, and common difference is -3. And we can use the formula for the nth term, which is a plus n minus 1 times d, and we would substitute a, d, and n value to get the 12th term. Lastly, practice problem 4. Problem states that problem wants to find out the sum of the first 10 terms of the sequence 1, 4, 7, 10. You would want to identify the first term, which is 1, common difference, which is 3, a number of terms is 10, and we can use the formula for the sum of the first n terms. In conclusion, arithmetic sequences are a fundamental concept in math. They are helpful for modeling and solving a different range of problems. That is it for this lecture. Thank you everyone for listening.